Assalamu alaikum. In this very short video, we are going to recall a very important concept that we learned in the earlier video, which is effects. But now we are going to discuss it with reference to the new information that we've learned, that is the sample spaces. We know that the random experiment can result in one of the possible outcomes listed in the sample space. So if I'm making an experiment of observing the gender of a person entering the university gate next, it can be the two possible outcomes can be male or female. And these are the simple events which are part of my sample space. Now, an event is defined as the subset of the sample space which have certain defined characteristics, such as I might be looking at the clock and all the possible outcomes are all the possible times that I can read from the clock. This makes up the sample space, and each of the possible readings that I can get from the clock forms one simple event. The collection of the simple events is the sample space. Now, I might only be interested in an event that the time is beyond 4 o'clock in the evening. So all the other times which do not satisfy this criteria are part of the sample space, but they're not part of this event that I'm interested in. Consider this experiment of rolling two dice and recording the sum. We have already seen this, and we've constructed the sample space for this. We know that the sample space for this experiment is 2, 3, 4, 5 up till 12. Now, if I define an event which I'm interested in as the event of observing a sum below 5. So now you can see that there are many values in the sample space, and these are the possible outcomes of the experiment that we have conducted. But this particular event does not include all of those possible outcomes. It includes only those outcomes in which the sum is below 5. So here, event is denoted as usually by capital letters, and here we have defined it as A. A consists of the values, the simple events from the simple events from the sample space which satisfy this criteria. And this is that the value of the sum is below 5. So we have 2, 3, and 4. The rest of the values, although part of the sample space, they are not part of this event that we have defined. We can define other events on the same sample space. Each element of the sample space is called a simple event, as we know. So 2 is a simple event, 3 is a simple event, and so on. We denote the events usually are denoted by capital letters, as we have already discussed, and the simple events are generally denoted by this capital E, and then a subscript, which can be a value, a number, the actual value from the simple event, or a subscript with only to denote which simple event it is referring to. And it can also be written using this model. We're going to see that in the later examples, how simple events are denoted. Events usually are denoted by capital letters that we've seen, and they constitute upon simple events having the desired characteristics. So here, the sample space included all of these simple events, but this particular event that we've defined includes only these 3 simple events. And we could have defined many other events on the same sample space. An event B could be all the outcomes which are only even numbers. So the composition of that event would be different from A. It might contain same elements as A, but the composition of this event would be different from A because it is based on a different criteria. Experiment, for example, consider this experiment, picking 2 marbles from a bag, which contains marbles of red, blue, and green color, and then we note the colors. So now since we are picking 2 marbles, there can be, the outcomes are every time we get 2 values and they form the simple event. So we pick up 2 marbles together and note the colors. We're going to note 2 colors, and this is one outcome from one trial. So it could be red and red. Both of them can be red, red or blue, red, green, red, yellow, all the possibilities with red, and then blue, 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 red, blue, green, and so on. So we list all the possible outcomes, and this is our sample space. Now, if we define an event of getting same colored balls. So now you can go back and analyze your sample space and find those outcomes which satisfy this criteria. We have this simple event which satisfy this criteria. Here we have the balls of same color. This does not qualify. This doesn't. So this one also not. Here, this one also satisfies the criteria. We have two same colored balls. Again here, and we have two yellows here. So the event will contain this event A will contain these simple events from the sample space, and the rest of them will not be included. So we have RR, BB, GG, and YY. Now we can have define another event on this sample space, which is the second ball was not green. Again, now we are going to pick those simple events in which this criteria is satisfied, in which the second ball is not green. So we are going to pick up all the entries where the second letter is not a G. So we have RR, RB, we don't include this, RY, BB, BR, we don't include this, BY, we don't include this, then GR, and so on. And this is what we get. We can have a third event on this also, and we can have many others. This one says that none of the balls were primary colors. So we know that R, G, and B are primary colors. So the only options that we have is yellow, yellow. Because if we pick yellow, red, there is one red ball, which is primary color, yellow, blue, it doesn't qualify, and yellow, green. So we have only one option, one element from the sample space, which goes into this event. The next important concept is modeling the events as Venn diagrams. Venn diagrams are graphical representations that depict the relationship and commonalities between different sets or groups, and we can use it to model the events and their relationships. Event is a subset of the sample space, and we can have many events defined on the same sample space. Of course, they're expected to have common elements, they're expected to have different elements, and they can be modeled using the Venn diagrams. Consider this experiment of rolling a die and recording the value. The sample space is very simple. We can have only one of the 6 possibilities, and we list them all to make up the sample space, 1, 2, 3, 4, 5, and 6. And we can have this one circle to model the sample space, and we've listed. Here is what was said in the first slide, that we can model the simple events by this capital letter and the subscripts defining those simple events. So E1 is for this, 2, 3, 4, 5. And there are many other formats, there are many other ways people do it. You can define your own notations and declare those before you use them. And but these are the standard ones. Mostly you're going to see the events or simple events being defined this way. Now, if we have an event that we observe an even value. So this is the event A. Going back to the sample space, we can see that this value is even 2, 4, and 6. So this event A has this composition 2, 4, and 6. Now we can demarcate this event here on this Venn diagram. And we know that this event A, since it includes these outcomes, so we draw a circle around it to model this event A. We can have another event, a value which is greater than 3. If we go back to the sample space, here we can find 3 values which satisfy this criteria, which are 4, 5, and 6. So we can draw another, the composition is written here, and we can draw another event, including these simple events. So here is B, and you can already see that B shares some 2 simple events with A. Then the third event, C, which is a value divisible by 3. If we go back to the sample space, we can see that only there are 2 values which satisfy this criteria, 3 and 6. So the composition is shown here, and we draw a circle around these values to represent the third event. And here you can clearly see that these events have some common elements. These events have elements which are different, and they do share, of course, since they've been derived from the same sample space, there is possibility of them having common elements. There is possibility of them having no common elements.